Hey everyone, welcome to this video. And in the previous video we have discussed the algorithm of how we can check whether a graph is a tree or not. Okay, so in this video I'll show you how you can code that algorithm, right? So the first thing that we need to do is we need to check whether the graph contains any cycle or not, right? So this is the first condition, and the second condition that we need to check whether all the components of that graph are connected with each other or not. Okay, so this is the second condition. Okay, so if these two conditions are satisfied for any of the graph, then it means that the graph is a tree, right? So let's see the code. Okay, so this is the basic code for a graph, right? And here I have created these two functions. So the first function is used to check whether the graph has any cycle or not, and these two functions I have explained in my previous videos. Okay, and this function is used to check whether all the components of the graph are connected with each other or not, right? So it's a basic DFS function, and we'll use these functions to calculate or to find out that whether the graph is a tree or not, right? So let me create another function here. Let's say utility function. Okay, so first I'll call this function is cycle function, and we'll store that in a variable. So here there are two parameters. The first one is the root node, which is 0, and the second one is its parent. So root has no parent, so let's say -1. Okay, and if the value of x is positive, then it means that the graph has cycle, so we'll simply return false. Okay, now the second function, which is connected components, and it has only one parameter, that is root. Okay, now see, here I have created this visited matrix. Okay, and I'm using this matrix in this function to check whether the node is already visited or not, right? And here in the second function I'm again using the same matrix. Okay, so first we need to mark all the nodes unvisited. Okay, so I'll copy this function here. Okay, so here we have marked the visited matrix as 0, and then we can run this function. Okay, so that's correct. Now we need to check whether all the nodes are visited or not. So int I is equal to 0, I is smaller than number of nodes. So the number of nodes is actually m, right? So what we'll do, we'll pass m as a parameter here. Okay, and use that parameter. So if any of the nodes are not visited, then we'll simply return false, right? Now, and if these two conditions are satisfied, then here we'll return true. Okay, and we just need to call this function in main, that is utility function, and we'll pass m as a parameter. So here n is the number of edges and m is the number of nodes in the graph. Okay, now let me store in some variable. Now if the value of x is positive, okay, if x is positive, then graph is a tree. Okay, else graph is not a tree, right? So let me run this. So it is compiled successfully. Now if I run this, so let's use this graph. Okay, this graph first. So here we have 1 2 3 4 5 edges, and the number of nodes are 5. The first edge is in between 0 1, then 1 2, then we have 2 0, 0 3, and 3 4. Okay, So this is the output, that is graph is not a tree because it has one cycle, right? Now let's run this code for this graph. So here we have 4 edges and 5 nodes, 3 4, then we have 3 0, 0 1 and 0 2. Okay, so this is the output, that is graph is a tree. Okay, so using this code you can find out that whether the graph is a tree or not, right? So that's it for this video. Thank you.